All right, let's talk about systems of equations. The hope is that by the end of this video, you will be able to use graphs to solve systems of linear equations. Well, what is a system of linear equations? Well, you see linear in there. We're used to graphing linear equations, maybe in the form that you recognize here, y equals mx plus b. You've seen this before. And to solve a system, well, solving an equation means we isolate a variable, we solve for it, we figure out what its value would be. Now to solve a system, notice that we have two variables here. So a system of equation is two or more equations, because you could actually have a system with more. So two or more equations with the same variables. In our case, they are x and y. Now you could have as many variables as you want, but you would need to have as many equations as variables in order to solve it. So we'll see in this case we have two equations, two unknowns, and we can solve this system. And we're going to check out how to do that by graphing. So follow along in the notes. We'll keep referring back to this vocabulary page so you can fill that in and be aware of the most appropriate vocabulary for dealing with systems of equations. Now let's first look at these two equations right here, this system, y equals 2x minus 8 and y equals negative x plus 1. As you can imagine, if we're going to solve by graphing, the first step would probably be to graph. And these are already in a form that we like to see, the slope-intercept form, our old friend, y equals mx plus b. So we have the slope here, it's 2, and the y-intercept is negative 8. So we'll start at negative 8 and we'll plot the slope. Slope is 2. And that's enough right there. We really, remember, how many points do we need to draw a line? Do we need 3, 4, what is it? Remember, we only need 2 points to actually plot a line. So I will plot this right here. And remember, our lines should always have arrows on the end. These lines don't draw them right away, but lines go on into infinity. They're not just part of the graph. So keep that in mind. All right, let's plot the other line now. It is y equals negative x plus 1. So our intercept, y-intercept is at positive 1, and our slope is negative 1. So we're going down 1 over 1, down 1 over 1, and so on until we plot enough points that we feel will help us graph this line well. All right, so let me draw that line in. And I want you to look at the graph, and I want you to look for the intercept, the intersection, excuse me. Where do these two lines intersect? And what could that maybe tell us about the graphs or about the system of equations and its solution? Well, let's see. What is this point, first of all? This point of intersection right here, this green dot. Well, it's at 3 in the x, negative 2 in the y. And it turns out that that is the solution to a system of equations, that coordinate, which makes sense. It's where they both meet. They both meet at the same point. That point makes both of these lines, both of these equations, true. So the solution is a coordinate, and in this case, it is 3, 2, or negative 2. Now, the last step we want to do is to check our solutions. This is always a good practice in anything we do, and if you remember, any coordinate we have is an x and a y value, so we can plug that into each of these equations to see if it indeed is a solution. So let's plug it in. Negative 2, I'm plugging into the blue equation. Negative 2 is y equals 2x, so x is now 3, minus 8, so negative 2 equals 6 minus 8 when we simplify, and negative 2 equals negative 2. Good, that checks out. So I want you now to try plugging in the red equation with the same point, the same x and the same y, because it should be true for both of them. So let's plug in for y is negative 2 equals negative x, which is 3 plus 1. Well, what is negative 3 plus 1? It's negative 2. So negative 2 equals negative 2, and there we go. It checks out. That is the solution to this system. The coordinate negative, or 3, negative 2, and we checked it in both equations here by substituting in. All right, well, let's check back. To solve a system of equations, what do we find? We find the graphs of each equation and their intercepts. the intercept being the coordinate where they cross. Now, the solution to the systems of equation, it would be an ordered pair or coordinate, an x and a y value at the same time. So when we solve for a system of equations, we end up finding both x and y. The solution is a coordinate x, y. All right, well, let's look at a couple examples. You can follow along in your notes and pause at any time if you think that you have an idea of where this is heading, and try it on your own and then check back in. All right, we have two different systems of equations here. Let's look at this first one, number 1 over here. The blue line is already in y equals mx plus b form. That's good news for us because we can plot that right away. So let's find the y-intercept of 7, and we plot up 1 over 2, up 1 over 2, up 1 over 2. And we will now draw that line. Let's draw that. All right, so hopefully you're able to draw these on your graphs that you have there, and you're using other colors if you have them available. It helps us see more clearly the picture that we are drawing. Okay, let's draw the red one. Now, -5 is the y-intercept, so we're starting down on the negative y-axis, and we are now moving down 5 and over 2. Our slope is -5 over 2, and we can do that in reverse as well. So let's do that, and let's plot it. So go ahead and draw, and I hope that this is a good reminder of you of how to plot graphs. So please take advantage of this opportunity to pause and get ahead and see how you do. See if you're keeping up with the ability to plot graphs from slope-intercept form. All right, well, what is the solution? We've graphed it. Now let's find the intersection. The intersection is at point -1, 2, 3, 4 in the x, and +1, 2, 3, 4, 5 in the y. So -4, 5. That is our solution. It is a coordinate. So the last step is to check that. So let's plug that into our equations and check our solution. So let's do blue first. We have x and y, -4, 5. So we'd have 5 equals 1/2 times -4 plus 7. 1/2 times -4 is really -4 divided by 2 plus 7. And that would end up being 5 equals -2 plus 7, and -2 plus 7 is 5. So that checks out. Now let's check the other one. Let's check the red one. Y equals -5 half x minus 5. So let's plug in y. 5 equals -5 halves x. Now x is -4. And that is minus 5. So 5 equals, now -5 times -4 is +20. So we have 20 over 2 minus 5. 5 equals 10 minus 5. And 10 minus 5 is 7. Just kidding, it's 5. And it checks out. Good. So now you can see another example. We plotted two lines, two linear equations. We found their intersection, which is a coordinate, and that is a solution in both the x and y values to both of these equations. So let's check out one more example here, because it's good to practice plotting from all different sorts of perspectives. And I actually had the wrong equation there, so let me get the right one in. For us, that equation should be x minus y equals 3. And what we need to do is turn both of these into slope-intercept form. So, well, you can plot from here. So it's whatever you choose. If you want to plot from standard form, you can. I'm going to turn these into slope-intercept form to practice. So I'll subtract x from both sides. I have -y equals -x plus 3. And I'll have to divide this all by a negative. So everything will get multiplied by -1. And essentially it switches the sign. So y equals x minus 3. All right, so we can plot that now. Y equals x minus 3 is a slope, or a y-intercept of -3, and a slope just of 1. So easy enough to find that. You plot it out. We'll draw our line. We'll get red selected here. Okay, I'll draw my line right through this. So it goes through the y-intercept of -3 with a slope of 1. Now let's look at the blue line. Blue line, 2x plus y equals 3. This is in standard form, so let's subtract 2x from both sides, and we'll have y equals -2x plus 3. We can plot that now. Where's the y-intercept, guys? Where is it? Y-intercept is at 3. And what is my slope? -2. So how do I move? I move down 2 over 1, down 2 over 1, down 2 over 1, and so on until I'm off the page. We'll extend our graphs like that. All right, so let's draw that line. Let's look for a point of intersection because that is the solution to a system of equations. Right, we'll extend that right there. Good. All right, do you see the solution? The intersection where these both cross is at the point 2, -1. So let's plug that in to each of these equations. So the first one, x minus y equals 3. So let's try that. If this is x and y, let's plug that in. 2 minus -1 equals 3. Well, 2 minus -1 is really 2 plus 1, so that's 3 equals 3. There you go. First equation checks out. Good news. All right, let's try the second one. 2x plus y equals 3. So that would be 2 times 2 plus -1, which is y, equals 3. Well, 4 minus 1, does that equal 3? Of course it does. 3 equals 3. And that is the solution to this system of equations. So let's check back really quick on our vocab. System of equations. It's 2 or more equations with the same variables. In our case, the 2 variables were x and y. To solve a system of equations, we graph each equation and we find their intercept. So we find their graphs, we find their intercept. And their intercept is a coordinate, and it is an ordered pair of x and y values that we can substitute in and solve for. So our steps, again, we graph the equations, we find the point of intersection, and we check both of the solutions with the coordinate, the x and y values. Good stuff, guys. We'll see you in the next video.